Thank you very much and welcome to our webinar series. I'd like to go over, before we get started, I'd like to go over the upcoming webinars. So this webinar today is a little special experience because it is taking 5 talks from our workshop that we just completed last week. And on October 29th, we'll be doing the same thing. So we'll be going over the PFAS rule implementation and treatment from our small systems workshop that we did last week. So it'll be similar to what we did today. Beyond that, on September 26th, there'll be a computation toxicology communities of practice talk. October 3rd, there'll be a tools and resources training research presentation. And then on October 9th, there'll be an emergency response research webinar. So I'm hoping you can also attend all of those webinars coming up and hope to see you then. Next slide, please. As I mentioned, today we have 5 talks. They come from our small systems workshop that we completed last week. So it'll be a little different format than we previously do on this webinar series. So we'll do 5 talks with a break at 2:30 for 30 minutes. And also we'll be doing questions for each speaker at the end of each specific talk. So if you have a question for James, for instance, in the first talk, please ask that question during his presentation because we'll spend about 5 minutes or so at the end of his talk to ask him questions, and the same for the speakers to follow. So we'll be doing questions. Usually we hold questions to the end of all the speakers, but we're not doing that because we have a number of talks today. Let's move to the next slide, and we'll start with James Hogan's talk, and I'll introduce him. So James has over 20 years of experience working on a variety of hydrogeology and water quality environmental issues from both the academic and public sectors. Presently, he works with the Office of Groundwater and Drinking Water at the US EPA, focused on improving EPA oversight of state primacy agencies and working with regional staff to ensure effective implementation of the national primacy drinking water regulations with a present focus on the PFAS regulation. And with that, we'll jump right into James's talk, and we'll then, when he's finished, ask questions. So James, are you there?
I am. Thanks, Tom. Appreciate the introduction. I'm going to share my screen here, and hopefully all will go smoothly. Very good. Well, thanks, everybody. Appreciate the opportunity to kind of talk about the PFAS National Primary Drinking Water Regulation. And what I want to do today is talk about 2 things in particular. One is I want to focus a little bit on an EPA-State implementation work group that we have that's helping us develop some implementation products for this rule. And then I want to focus on the initial monitoring requirements, which are really the first requirements that primacy agencies as well as water systems that need to implement the PFAS regulation are going to need to meet. So I want to start with just a brief disclaimer. Part of this here is just to say that, obviously this is a presentation we've tried to be as accurate and consistent with the regulation, but if in any situation, anything I say is in conflict with the regulation, obviously the regulations in the Code of Federal Regulations, CFR, are what is the binding requirement. But hopefully the information that's provided here will be useful. And especially when I get into the implementation portion of the talk, you'll see that there are CFR citations. So you can always go back to the initial CFR citation if you have any questions about any of the specific things that are mentioned on that slide. So just by way of introduction here, what I want to do today is we'll go through 4 different parts of it. An introduction to this talk, which is pretty brief, and then again focus on those 2 main things: our efforts with the PFAS work group to help support the development of implementation products for the rule, and then the initial monitoring requirements. And then as time allows, I'll just have a brief conclusion and hopefully have some time for some Q&A. So introduction here on the PFAS regulation. I think probably most everyone on this call knows that back in April of 2024, the EPA published the final PFAS National Primary Drinking Water Regulation. This is in subpart Z of 40 CFR 140. And at around that same time, the EPA initiated a joint EPA-State work group to help facilitate implementation. And in this effort, what we did was um, what I want to say is that I want to cover in this the participants in this work group, the work group charge, and some of the planned products that we've got going on. And then in the second part of the talk, again, going to focus on those initial monitoring requirements, excuse me, and talk about three specific things really: where sampling needs to occur for initial monitoring, the frequency of sampling, and then the use of pre-existing data, which is an area where we've received a lot of questions and is an important part of the initial monitoring requirements. So let's focus briefly just on this PFAS work group. Um, and as I said previously, as the PFAS rule was being finalized, the EPA worked with our colleagues at ASDWA, the Association of State Drinking Water Administrators, to identify a number of primacy agencies who would work with us as part of this EPA-State PFAS implementation work group. As I said, a joint effort between EPA and these primacy agencies. And I think I've said this several times before, but it bears repeating again. The goal really for this work group is to ensure the successful implementation of the um, final PFAS national primary drinking water regulations and help develop appropriate implementation guidance. These implementation guidance are guidance that EPA is producing, but we think having this work group will help us get the best and most useful guidance for our primacy agencies and water systems across the country. So who's on this work group? Well, this is a list of who's on it. On the left-hand side here, you can see there's a number of folks in the EPA offices. Those include in the Office of Groundwater and Drinking Water, the top item there, and that's the group that I'm in. And there's a lot of acronyms here. SAB is the Standards and Assessment Branch, and that's the branch that I'm in. And myself and my colleagues, Rebecca Feldman and Allison Treglia, we're the three folks who help lead this work group and help make sure that this work group is making progress in helping uh, identify and address some of the implementation products that are being developed. We also have colleagues from a number of other offices or other areas within OGWDW, including in our Standards and Risk Management Division, who are the folks involved in writing the rule, as well as our colleagues from the Technical Services Bureau, who were the folks dealing with the analytical methods and folks like that. So we try to bring in all of these people who have some additional resources that can help provide support to this work group. And then other offices within EPA, from the Office of Research and Development. Tom Speth, who just introduced me as a member of the work group, who helps us with PFAS treatment. We also have our colleagues from the Offices of Enforcement and Compliance Assistance, who deal with our enforcement side of things. And then also we work with all 10 of our EPA regional offices. So we have a lot of EPA folks, but on the right-hand side is the folks that I really want to focus more on, which is our primacy agencies out there. These are the states that are out there that are helping implement the National Primary Drinking Water regulations across the country. And you can see there are 10 states there, as well as the last item is Guam, a territory. And so we've got a good representation, and our colleagues from ASDWA helped us develop these state participants, and we really appreciate their efforts in this work group. They've been really instrumental so far already, and I think will continue to be instrumental in helping us develop the best products that we can. So as you can see, there's a number of state agencies that are really helping support this effort. So what does this work group do? Well, this is the work group charge, and I'm just going to highlight a couple things on here that are in bold, right? The main thing that this work group does is it works jointly to ensure the successful implementation of the final PFAS National Primary Drinking Water Regulation. And it does this through three primary activities. The first of these is to identify needed PFAS implementation products. And this would include related training as well as written products, which I think is what most people think of. And then the second item is to provide input on and review of these products. And this is the main thing that this work group really does. And the work group's been reviewing a number of products already and will continue to review products over the months to come. And lastly, through this work group, we also hope to share information on other efforts related to effective rule implementation. And this would include things such as technical assistance, including water TA and funding opportunities, for example, through the Bill Emerging Contaminants funding. So this is the work group charge. We've been active since early 2024, as I said earlier, And our plan is to stay active at least until all these implementation products are addressed. And at that time, we'll decide if there's a role to continue this work group for sort of ongoing facilitation of the rule or not. That's a decision we'll make at that time, but we'll continue at least through that time period. This is just a high-level summary of the planned products that are out there, in sort of roughly the order in which some of these things are being developed. Um, the first item there is quick reference guides and fact sheets, and we've got about 9 of these total. And these fact sheets are covering a variety of topics. One's just an overview of the rule. We also have one focused on initial monitoring, hazard index, things like that. So we're hoping to get these fact sheets out soon. They should hopefully be coming out in the weeks to months to come, here relatively soon. We're in the final stages of review of that. We're also looking to develop some training for primacy agencies, TA providers, technical assistance providers, and the EPA regions. And this is designed to be about a day-long training on the PFAS rule. And this would also include some workshop activities, some sort of hands-on calculation and sort of digging into the requirements of the rule and kind of dealing with some of that. Um, then we also have PN and CCR templates, which are things to help water systems and primacy agency help communicate, provide required communication for PFAS where necessary under the public notice and the consumer confidence report. I think as many folks on this call know that the Consumer Confidence Reports was updated to CCR3 updates, and our templates are designed to reflect sort of those updates because those happened at roughly about the same time as the PFAS rule. And then lastly, we have sort of 3 of our bigger products: a small system compliance guide, PFAS treatment options, selection and waste disposal, and then a PFAS rule implementation guidance. These are sort of larger guidance documents. And with these documents, these are sort of going to combine a lot of that other information that we've already provided and provide a sort of synthesis and share even more information. And hopefully, well, those will be some of the last products that this work group develops. Okay, so that's just a brief overview of what the work group's working on. Um, and I just want to make you aware of that. We're hopefully going to be having some of those products coming out soon. And so look for that. And now I want to pivot to talk about the second part of my talk, which is some of the initial monitoring requirements. And as I said previously, the initial monitoring requirements are the first thing that um, water systems and primacy agencies are going to need to implement under the final PFAS National Primary Drinking Water Regulation. Okay, so I want to start here by just talking about some of the general requirements under this rule. The first thing is that um, this is a rule that's required only for community water systems and non-transient, non-community water systems. Those are the systems that must comply with the PFAS National Primary Drinking Water Regulation. And so for all of these systems that are community water systems or non-transient, non-community water systems, systems will need to monitor, and that's going to be required at each entry point to the distribution system. And the second little bullet here is one that I really want to stress. We've received a lot of questions about this. Consecutive system interconnections. So the interconnection between one water system with another water system that's providing finished water, that interconnection is not considered an entry point. There does not need to be sampling at that entry point. That wholesale system will be collecting that PFAS data. If there's a violation there, they have to communicate that information to the consecutive systems who are receiving that water. So those interconnections do not need to have do not need to be monitored. But those systems are required to implement this regulation. So they will need to provide that public notice. They will need to put their data into the consumer confidence reports or issue public notice, those types of things. Those will all be requirements that those systems will need to meet. So just keep that in mind as something that we've received a lot of questions on. And the second bullet point is just noting here that transient non-community water systems are not required to comply with the PFAS National Primary Drinking Water Regulation. So even if they're receiving water from a community water system, they're not required to meet these requirements and would not be need to issue public notice or do any of those other things. Some of those things might be protective things, more protective of public health. Certainly wouldn't discourage that, but they're not required to meet the regulations. And lastly, I just want to note here on the bottom, you can see that CFR citation in the slides that come. You'll see that on all those things. That's what I was talking about earlier. That's where you can find information about, in this particular case, who needs to comply with the PFAS rule. I want to talk about some of the analytical requirements for the rule. So those systems that need to comply with this regulation, those community water systems and non-transient, non-community water systems, they must use approved analytical methods to demonstrate compliance with the requirement. Those approved analytical methods are shown in the table below. They're EPA method 533, and it has a very long name there, which I'm not going to go all the way through. But Will will talk much more detail about this in his presentation that follows mine. And then EPA method 537.1 version 2. The second requirement is that those systems must also ensure that all of their results, all results provided by the laboratory are reported to the primacy agency. And then the primacy agency would be using all those results when determining the required sampling frequency. And we'll talk a little bit about that more later when we talk about the initial monitoring requirements. So states must also use certified labs beginning in June 25th of 2024. Those all samples must be analyzed, obviously, at an EPA or state certified lab. And of course, they must be samples must be analyzed using an EPA approved method. Um, in order to receive this certification, those laboratories must analyze performance evaluation or PE samples that are acceptable to EPA or the state at least once during each consecutive 12-month period. And obviously, again, beginning in that June 25th of 2024, they must achieve those quantitative results for those PE samples um, within the allowed acceptance limits, which are 70 to 130% of those true values. So as I said previously, beginning on that date, June 25th, laboratories must report data for concentrations as low as the trigger levels for the rule. Prior to this, for some of the initial monitoring data for data that was collected previously, data above the trigger levels can be acceptable, but we'll talk about what that may mean in terms of what that means for reduced monitoring in a little bit. So PFAS sampling, I want to thank my colleague, Michelle Carapondo, for providing the next couple of slides. We've received a lot of questions about appropriate methods or appropriate sampling procedures. And several of these slides are guidance. I'll try to kind of go through some of this stuff. Some of these things are requirements within the method as well. So the first item here is that samplers must wash their hands before sampling and wear nitrile gloves. These are requirements of the method. Gloves should be changed between each sampling location, but that's not necessarily a requirement. That's a should. Sample bottles should be made of polypropylene fitted with polypropylene screw caps, or polyethylene bottles fitted with polypropylene screw caps, or other plastic materials that meet the method quality control requirements. Samples should not come in contact with any glass containers or pipettes. You want to stick with just those plastic materials that are allowed under the methods. And samplers should wear clothing that's made of 100% cotton and avoid using fabric softener. Some of these things are best practices, just again, trying to minimize the chance for any potential contamination. Um, and, just some of these other sampling procedures, that, that there is the possibility of samples becoming contaminated with clothing or equipment. And so there's some items here of some things to kind of think about. Again, these aren't requirements. These are just some things that may contain PFAS and just things to be aware of, such as, trying to minimize the use of, stain repellent or water repellent clothing when you're out collecting those samples. Try to avoid using equipment or bottles that are can contain Teflon. Um, or use of waterproof paper, some of these things which contain PFAS chemicals within them. Just try to avoid that while you're conducting any sort of PFAS sampling. Again, these are some best practices, not requirements of the regulation. Um, Lastly, do want to talk about the field reagent blanks. Um, and the field reagent blanks are used to identify contamination within the environment. And these are required for both method 533 and 537.1. The field reagent sample is basically a sample that's prepared in the field by transferring an unpreserved reagent water into a sealed sampling bottle in the field. And it's designed just to see if there's any contamination in that location from the environment that may be causing and adding to the sample itself. So, whenever you go out and collect a sample, there are three bottles that'll be in your sampling set. One is this for the field sample that contains the method preservative, and that's the sample that you're going to be collected. The other one is a sample filled with that PFAS-free reagent water, and that's filled in the laboratory. And you take that out in the field, and then that gets transferred to the third bottle, which is the field reagent blank, which contains the method preservative as well. And so you do that again in the field. And then obviously, if your sample contains any PFAS, then the field reagent blank would be analyzed. And if that field reagent blank has values that are above um, a threshold, and that's shown here as being 1/3 the MRL value, in other words, that would be indicating a detection of PFAS within the field reagent blank, um, then that sample would be invalidated and arrangements would need to be made to collect a new set of samples. So again, that field reagent blank is going to help protect and make sure that those samples are not being contaminated by other things in the environment that is truly representing the PFAS that's in the water supply that you're sampling. Okay, that covers some of the analytical methods. Now I want to pivot to talk a little bit about the implementation timeline for the rule. So the implementation timeline here starts on that June 25th date, which I've talked about previously. That's the date when the regulations are in effect, and that's when all of those analytical requirements that I just talked about in the previous slides must be met. Second one here is a date that is 3 years out after the rule promulgation, so April 26th of 2027. And this is really important because this kind of covers the main thing that we want to talk about here in this section. And that's the date when all initial monitoring requirements must be reported to the primacy agency. And after this date, that's when compliance monitoring begins. And systems would need to begin to report, need to be conducted reporting and record keeping compliance, and monitoring and reporting compliance determinations would begin. Systems would also need to conduct PN as necessary for community water systems and report on those results within their CCR. Now, this PN here would really just be for failure to conduct the monitoring, because this comes up to our next slide here, which is 2 years further, which is April 26th of 2029. And this is the date that the MCLs become effective for the community water systems and non-transient, non-community water systems. So the MCL compliance determinations begin at this date, and that's the date when PN would be required for those MCLs. Okay, so a few slides here on some of the general monitoring requirements. Water systems must take all samples during normal operating conditions at all entry points to the distribution system. And if a water system draws water from more than one source and those sources are combined before distribution, the water system must sample at the entry point to the distribution system during periods of representative or normal operations. So if you're mixing two groundwater wells, you want to be sampling at a time that those wells are operating in what is generally your sort of normal operating conditions, not when just one of them is operating, if that's not your normal operating condition. Um, In the interest of time, I'm going to skip over these definitions, but those will be available to you all in the handouts. Um, and I just want to kind of cover it on this slide here. And this just talks about the regulated PFAS under the rule. And you can see here, this is kind of broken up into three different parts. I'm going to talk about the top two on the first here, which are PFOA and PFAS. It shows here that those two contaminants are not part of the hazard index. They have MCLGs, so that's the maximum contaminant level goals of 0. And then their MCLs are 4.0 nanograms per liter. And then the trigger level is 2.0. And we'll talk about the trigger level in a little bit going forward. The next four compounds are all part of the hazard index. I'm not going to read each of their names there, but they're shown there. Three of these have individual MCLs and MCLGs. So that's all except for PFBS that you can see here, and those are listed as NA for those two contaminants for that. And so for all of those, they all have trigger levels of, or those three compounds have trigger MCLs of 10 and trigger levels of 5 nanograms per liter. But all four of those compounds are part of the hazard index PFAS. Um, and there's a formula that takes those values and generates the hazard index. It makes it sort of relative to 1. So if your value exceeds 1, the system would have an MCL violation. If it's less than 1, you would not have an MCL. I should say exceedance. A violation would be based on the running annual average. And that's something that we won't have time to talk about today. Um, and the trigger level for those is 0.5. Okay, so I want to focus on the last couple slides here on the initial monitoring requirements. So this slide shows the minimum requirements for each of those regulations. And I want to start on the left-hand part of this here, which is groundwater systems that serve less than or equal to 10,000 people. So those systems are only required to collect 2 samples per year. And those are taken 5 to 7 months apart. Um, and then the next two, which would be any groundwater systems that are greater than 10,000, sort of greater than 10,000 people, or any surface water systems, those would be required to collect 4 samples per year, taken 2 to 4 months apart, and those have to be collected quarterly throughout the year. Um, and note as well, primacy agencies may always require more frequent monitoring on a system by system basis or within that primacy agency. Just want to highlight here as well that GUDI systems or systems that blend surface water and groundwater before that entry point, all those systems would be required to um, uh, operate as if they're a surface water system. So collecting samples quarterly, collected 2 to 4 months apart. The only situation would be if you had a groundwater system and it blends groundwater sources. Those would be based on the system size. All right. Previously acquired data. Just want to highlight here that in the regulation, we really wanted to allow for previously acquired data to be used. We know many systems are collecting UCMR data. We know that many states are already conducting PFAS sampling or already have PFAS regulation. Um, so we wanted to allow as much of that previously acquired data to be accepted. And it can be accepted, whenever they're using the appropriate EPA methods and were collected on or after January 1st of 2019, excuse me. Um, and they must otherwise meet those timing requirements that we talked about previously. Um, Acceptable data, starting on June 25th of 2024, before that date, I should say, must not exceed the MCL. So you could have a data reporting limit that has a value of, 4 parts per trillion for PFOA, and that would be an acceptable value. But it wouldn't reach those trigger levels. After that date, you would need to meet the trigger levels. As we talked about, that was a requirement for the analytical part of the rule, the analytical requirements of the rule. And just to note that if you are using data that doesn't meet those requirements, those systems may not be eligible for triennial um, monitoring once ongoing compliance monitoring begins. Um, and then lastly, if systems have multiple years of data, which may be the case for states that have regulations, the state should be using the most recent data to make the determination once the federal rule goes into effect. So again, this is just showing here that missing data can be used. So if to help fill in some of the gaps. So if you're a surface water system or a GUDI system or a groundwater system serving less than 10,000 people, um, and you don't have all the data to fill in all 4 of those calendar quarters, the system or the state may allow the system to collect in a calendar year samples in each of the quarters that were not representative. So, that again, we're sort of filling in those missing calendar quarters, if you will, provided that they're 2 to 4 months apart from the data that was previously collected. Likewise, for those groundwater systems serving 10,000 or fewer, If you're missing one of those samples, you can kind of fill that in by having a sample collected in another year that's 5 to 7 calendar months apart from when that previous sample was collected. So I think one of the best ways to do this is to kind of see this visually. In the interest of time, I'm just going to kind of go to that figure there, and you can see the system in 2022 collected 2 samples in January and July. So the question is, what additional steps does this system need to take in order to satisfy this initial monitoring requirement? Well, they would need to collect samples that kind of fill in those additional quarters. So they might collect a sample in, say, March or April of a subsequent year, so in, say, in 2025, and then say in April or November of that year too, to kind of fill in those quarters. So that you have 4 calendar quarters represented. Okay, and lastly, just want to talk about how you determine that ongoing compliance monitoring. And just kind of want to note here that, the last 2 bullets. So if the system was a surface water system, they have collected 4 samples. Say, for example, if all of those reported sample concentrations were below all of the trigger levels for all of the regulated PFAS, then the primacy agency may allow compliance monitoring on a triennial schedule. If any of those PFAS monitoring results meets or exceeds the trigger level for any of those sampling points at that entry point, um, then that system would not be eligible for triennial monitoring and would have to start on quarterly monitoring at the start of ongoing compliance monitoring. So just to kind of see this visually, were all of the individual monitoring results below the trigger level for the 5 regulated PFAS and the hazard index? If the answer to that is yes, then the primacy agency may allow compliance monitoring on a triennial schedule. If the answer is no, they must begin ongoing compliance monitoring on a quarterly schedule. So I rushed through some of that because I know we're pressed for time on some of this, but hopefully um, you kind of got the gist of it. We had a discussion of the PFAS work group and some of the implementation products that we're working to develop. And then on the initial monitoring, we covered a number of things. We talked about some of the general requirements for monitoring. We covered the fact that this consecutive system interconnection is not a place where monitoring needs to occur for the PFAS rule. But all other entry points to the distribution system that are if a community water system or non-transient, non-community water system must conduct initial monitoring and then ongoing compliance monitoring. And lastly, we talked about how to determine what the monitoring schedule would be based on those results. So hopefully that was a good introduction on some of those requirements. And with that, I will turn it back over to Tom to see if we have time for a few questions.
Maybe I'll ask a few of those. So when and
Sure
do
thing.
the EPA PFAS MCLs supersede the individual state published MCLs?
Yeah, sure. So this is an interesting question, right? One of the things with it is it kind of depends a little bit, right? So the state primacy agencies are going to kind of need to take a look at the federal requirements, and then if they have standards that are more stringent than the federal requirements, then those may be what they say. We're going to continue with those requirements. If not, the state would need to modify its regulations and determine what those new values would be, and what time frame with an individual state that would occur. It sort of depends on how that state rolls it out. So I think some of those questions you need to talk to your primacy agency to kind of get those specific details. But without a doubt, the federal requirements would go into effect on that April 26th of 2027 date.
Okay, and we have a bunch of questions about EPA method 537.1 version 1. Is that acceptable or must it be version 2?
The rule requirement requires version 2. We're aware of this issue. It's something that's being evaluated within EPA. So as of right now, the regulation it would not allow a version 1 method.
And finally, one quick one. So if a transient system does voluntary monitoring and PFAS is detected, does that trigger reporting requirements similar to a community water system or a non-transient, non-community water system?
No, I mean, there's not a requirement for that because they're not required to conduct that monitoring. That would be voluntary monitoring, and certainly EPA would encourage that system to provide notice and to their customers of those values. But but it's not a requirement because transients are not using, the PFAS contamination is a chronic contaminant, so it's not based on one small sampling. Transients are designed for folks that are not using the water regularly. So,
Okay, thank you, James. Thank
all
you so
right,
much for your
appreciate that.
presentation.
Sounds good.
Thank you so much. We'll move right to Will Adams' presentation. While he's getting his slides up, I'll read his introduction. So Will is a chemist with EPA's Office of Groundwater and Drinking Water Technical Support Branch in Cincinnati, Ohio, where he is involved with drinking water analytical method development and technical support. The Drinking Water Alternative Test Procedure ATP program, evaluating new and updated drinking water methods for regulatory compliance monitoring, and the UCMR program as a technical and analytical method resource. He has 17 years of research experience in EPA's analytical method development, and with a focus on LC-MS-MS. And with that, I'll pass it right to you, Will.
All right, thanks, Tom. Yep, so speaking on the PFAS analytical methods and how they relate to the National Primary Drinking Water regulations. So whenever I give a presentation on any methods that are developed within EPA, I like to give an overview of our method development process. This process typically takes anywhere from 1.5 to 2 years because we go through a series of ruggedness testing and evaluation with our methods to ensure that we're producing valid, precise, accurate results from that methodology. So obviously, we'd begin with target analyte selection. So for drinking water, we'll look to things like the contaminant candidate list for drinking water. We'll consider emerging contaminants that may be of public concern, but we need to know what we're looking for so we can identify analytical techniques to measure for those contaminants. So at this step, once we know what we're looking for, we select instrumentation based on scientific literature, preliminary experimentation. In the example of PFAS, if we're doing an LC-MS-MS analysis, we'll optimize our chromatograph, the analytical columns, eluents, gradients associated with the chromatography, optimize the mass spectrometer from the detector side of things. This is just to establish that we can measure the target analyte. Once we know we can have a measurement, we begin our performance data collection. So often we begin with a system background check. This is often a laboratory reagent blank looking for any types of carryover that can occur for that analysis, contamination that can come from different sources, including the instrumentation itself. Then we move on to our quantitation limit determination. For our in-house methods, we use the LCMRL calculation. This is a lowest concentration minimum reporting level. So within our EPA methods, we often don't require the calculation of a quantitation limit. We'll include what's known as an MRL confirmation in our methods. That's just to assess that a laboratory can meet quantitation levels that may be required for a particular application. On the side of determining a quantitation limit, we use this LCMRL calculation, which is a predictive calculation based on accuracy and precision calculations. We then move into precision and accuracy measurements. So say for an organics method, we'll look at percent recoveries, we'll look at percent relative standard deviations. The acceptance criteria for all of those parameters does depend on the type of analysis you're conducting and the concentration of the analytes you're looking for. So we tend to have wider acceptance criteria for analytes that are at the lower end of quantitation, just because that's where you start to see some variance occurring with the measurement. We do evaluate in different matrices. So for drinking water, we may look at a reagent water sample, fortified, a ground source tap water, and a surface source tap water. So that's really assessing any types of matrix effects you may get from the analysis. So we may look at a high TOC water coming from a surface source. We may look at a high carbonate or high mineral content, hardness, water coming from a ground source to ensure that matrix effects aren't affecting our measurement and results. Once we've established that the analysis is precise and accurate, we start looking at a storage stability study. So within our drinking water methods, we do establish preservation as part of the analysis, how long you can hold samples, how long you can hold extracts that may come from those samples. We typically go out to around 5 weeks, looking at any potential chemical degradation, any potential microbial effects that could occur with the target analytes. So often you'll see in our methods, so for example, there's a 28-day sample hold time that's coming from this storage stability study, because everything within our methods are empirically based, anything that's prescriptive. And for the storage stability study, if we go out for 5 weeks, that's 35 days. If we're measuring every week, you use a degree of freedom, you get 4 weeks of a reported value, and that's where you get the 28 days of a hold time. We then send the all of this, prior is single lab determination. So we want to ensure that other laboratories can get similar and comparable performance results. So the method will be sent out for a multi-lab demonstration. We typically have at least 2 outside laboratories evaluate the method in their local tap waters and in reagent water. We can have more, and we encourage other labs to participate if they're able. So for example, method 533 actually had 8 participating laboratories in the multi-lab demonstration. So obviously the more the merrier. And then the method gets submitted for EPA clearance. So there are 2 EPA PFAS drinking water methods that are approved within the National Primary Drinking Water Regulations. You just heard James talk about them. And there's going to be some carryover with my presentation with some of the points he made in his presentation. So we have EPA Method 533, which was developed in the Office of Groundwater and Drinking Water, and EPA Method 537.1 version 2.0, which was developed in the Office of Research and Development. Both methods were developed in our labs in Cincinnati. The primary difference between these 2 methods really lies in the quantitation technique used in the methods. Method 533 is a isotope dilution quantitation technique, and then method 537 is a internal standard quantitation technique. There are some slight differences in prescriptions in the methods and the target analyte list. But for the purposes of the National Primary Drinking Water Regulations, we consider these methods comparable. As was just discussed, EPA Method 537.1 version 2.0 is the current approved method. There are earlier versions that are not approved for compliance monitoring in drinking water. So both methods are liquid chromatography tandem mass spectrometry methods. You may see this listed as LC-MS-MS, or here it's called a triple quad. They also involve electrospray ionization. So effectively what happens is you go through a sample preparation process, in this case a solid phase extraction. That extract gets injected into your instrumentation, moves through a chromatographic column or an analytical column, where all of your target analytes get separated by retention time. That's the basis behind chromatography. It then moves into a nebulizer or the electrospray, where it gets ionized and then moves into your triple quad. So quadrupole 1, you identify the ionized parent or precursor ion. That ion then moves into quadrupole 2, where it gets fragmented into daughter or product ions, and then those ions get identified in quadrupole 3. So that's effectively how the measurement occurs, and then it's all based on abundance of those analytes. These are some examples of LC-MS-MS instrumentation that we have in our labs in Cincinnati. We typically don't require any type of vendor prescriptions in the methodology, as long as the scope of the method and the specifications for instrumentation in the methods are met. So these are both fairly modern pieces of equipment, so they have good sensitivity. The technology has improved to a point where we can actually measure fairly low for analytes like PFAS. So the instrument on the left is an Agilent system, and the instrument on the right is a water system. Any applicable system will work as long as it's considered in the LC-MS-MS with electrospray ionization. So what I'll do here is go through some of the parameters associated with each method and how the method describes those parameters. So in terms of reporting limits, again, for a single lab determination, we use the LCMRL calculation. Our in-house laboratories saw 1.4 to 16 nanograms per liter as a quantitation limit for these methods. If moving into sample collection, you have, again, samples are collected in polypropylene or polyethylene glass, or is not allowed, and it's 100 to 250 milliliters of sample. Preservation is something that we do consider in our drinking water methods. I talked a little bit about the storage stability study. That's where this gets evaluated. So refrigerate samples less than or equal to 6 degrees, but we don't want them frozen. The basis behind not freezing samples typically lies in sample bottle integrity. It's not really a case of we're concerned about loss of target analyte in the sense of degradation. There's just a concern as water freezes, it expands, and then you can have a big problem in your hand with a broken bottle. We use ammonium acetate method 533 as the preservative, and then it's a 28-day sample hold time and a 28-day extract hold time. Sample prep, I mentioned before, solid phase extraction. So we're dealing with drinking water samples here, which tend to be much cleaner matrix samples to analyze. We primarily use solid phase extraction in these methods as a concentrating step, although it does remove the preservatives that are present in the sample. Our drinking water methods do have a fair amount of quality control associated with them. So we do precision and accuracy demonstrations, like I mentioned in the method development section, quantitation limit confirmations, quality control standards, which are often the second source standard if they're available, calibration checks. This method uses isotope dilution analogs and isotope performance standards for quantitation. Then we have a series of blanks, laboratory reagent blanks, field reagent blanks, fortified blanks, and then our fortified matrix samples and duplicates and field duplicates. Method 537.1 version 2.0 has very similar parameters and results in that methodology. Again, it's low nanogram per liter quantitation limits, in this case 0.53 to 6.3 nanograms per liter. Again, we're using polypropylene and polyethylene bottles, 250 mils of sample in that case. Preservation is similar to method 533 with the exception that trisma is used as the preservative in this case. It's important to note that both of these methods were really developed at different times by different groups, so you can see some slight differences in what's required within the method. But again, it's important to note that all of the validation and performance data were collected under these conditions. So we have empirical evidence supporting the results that we have and ensuring that the performance of the method is consistent. Because at the time there was no antimicrobial added to this method, it has a shorter field sample hold time at 14 days, but the extract can still be held for 28 days. Again, sample prep is solid phase extraction, primarily there for concentration. Quality control is very similar to method 533, with the exception that this method is an internal standard quantitation. So it uses internal standards and surrogate standards to do that calculation. All of our methods and both of the approved methods include an MRL confirmation as part of the method quality control. As it relates to the National Primary Drinking Water Regulations, this is the laboratory's ability to meet the practical quantitation levels that are listed within the regulations. In this instance, the minimum reporting limit for the method is your quantifiable value. So if you can confirm an MRL at or below the PQL in the regulations, then you're meeting the regulations with that requirement. And the sections listed here are where you can find the MRL confirmation with each method. We often do get questions on quantitation versus detection, so I did want to include a slide here to talk a little bit about that. So regarding a practical quantitation level, as it's referenced in the PFAS regulation, it's effectively a result that can be reliably quantified within certain limits of precision and accuracy. And The precision and accuracy is really the key point here when it comes to quantitation. Often with a detection limit calculation, so you may be familiar with MDL calculations in 40 CFR Part 136. Those results are basically a reliable discrimination from a blank. So effectively, can you get a signal? Can you detect a signal? Now, in both instances, you can have statistical approaches applied, and that's fine. But really, the key difference is that the detection limit calculation is primarily a precision measurement agreement among replicates, whereas the practical quantitation level also accounts for accuracy or percent recovery of those analytes compared against an expected or true value. So what type of analytical concerns do we have with PFAS? So one thing that I like to point out is that while many PFAS all share characteristics of a hydrogen being replaced by a fluorine, the chemical properties and the molecular properties of these analytes really varies based on often carbon length and chain length of those molecules. So as you get more carbons, you tend to get a more hydrophobic analyte, and as a mixture contains hydrophobic analytes, it can have certain effects on homogeneity. So whenever we're developing a method, we have to take these things into consideration. Certain classes of PFAS have to be looked at differently analytically, and that also includes how we sample those analytes. So it's a point that we have to consider in our method development. We also have to consider background contamination. So we've seen in-house, without any kind of mitigation, 100 to 500 picograms per liter of PFAS, and often it's specific PFAS that we'll see coming from several different types of sources, either the instrumentation itself, solvents and reagents, laboratory materials, or even the laboratory air itself. So how can we try to mitigate that contamination? So we'll look at things like if any glassware is being used, pre-clean, muffle that glassware, do the same with any plasticware that's being used, and then maybe put those materials in resealable plastic bags that are PFAS free. This can help protect the materials from any type of lab contamination that can occur. We're dealing with organic solvents, so we often use positive displacement pipettes, but use disposable tips. We found that glass syringes and micro syringes can actually have some carryover of contamination of PFAS. Do proper calibration. So these methods do require forcing through the origin or zero with a regression fit that's used in the calibration. So that's there to help mitigate some background PFAS that can occur. And then also use delay columns. These are designed to help mitigate any PFAS contamination that can occur from your mobile phases prior to injection. All of our methods require an initial demonstration of capability. This is an example for PFAS. So we do a system background check, reagent water precision and accuracy measurements, and then the MRL confirmation that I mentioned. So the methods all speak to the acceptance criteria for all of these parameters, and you must meet them as part of that initial demonstration. As far as an analysis batch goes, it starts with an initial calibration. So 5 calibration standards minimum. The lowest level needs to be at or below the MRL that's been confirmed via the method. Initial calibration is not really required for every analysis batch, but you would need to begin the batch with at least a low-level calibration check or a low-level CCC. So that's going to be at your MRL. It's then followed by other QC samples, LRBs, your blank. A fortified blank is just reagent water with your target analytes added. All of those concentrations for the FRB get rotated between various concentrations. Field samples, you can have no more than 20 field samples within an analysis batch, and then no more than 10 in between various calibration checks. So there needs to be a calibration check mid or a high-level calibration check every 10 samples, and then at the end of your analysis batch. There are additional QC samples that are required. the QCS I mentioned, which is typically a second source standard, but you can refer to the methods to see exactly what's required. Fortified sample matrices really test to ensure that that matrix effect that I talked a little bit about, and then field duplicates and FRBs are also required per the methods. So this is an example of the analysis batch associated with two methods. I would say that this is an extensive analysis batch, and I would hesitate to call it a worst case scenario, but this is as many samples as you would need to analyze within a batch. Some of this could be shortened. I mentioned the calibration could just be a CCC, depending on if you can attribute that batch to an existing calibration curve. And then also a field reagent blank is not required within the methods or the regulation unless you have a detection of an analyte greater than or equal to the MRL. So this is a case where a field reagent blank was analyzed with every field sample, but it's not required. In terms of chromatography, this is the suite of the entire list of method 533 PFAS. The one point I'll make here is if you look at around 10 minutes and 13 minutes, so again, chromatography is based on a retention time. You can see that the isomers are showing up for PFHXS and PFOS. These have to be accounted for in your samples. So there are technical standards available for all of the regulated PFAS, and there may even be quantifiable mixes available for those analytes. At a minimum, all of the isomers have to be identified via retention time, but then the methods speak to how to quantify depending on if a quantitative standard that has mixed branched and linear isomers, if it's available. It's similar to with method 537.1. Again, you see the isomeric peaks listed here, and again, they have to be accounted for. Calibration, I talked a little bit about the quantitation techniques. Method 533 is a isotope dilution technique, and then method 537.1 version 2.0 is an internal standard quantitation technique. Each of these, it's effectively isotopically labeled analogs of your target analytes and where they're added in the process. Isotope dilution is added pre-extraction, internal standard is added post-extraction, but it also has the surrogate standards that have acceptance criteria associated with them. So from a regulatory perspective, we consider these methods to be comparable in terms of quantitation. There are at least 5 calibration points that I mentioned before required. A linear quadratic curve forced through 0. The lowest cal point needs to be at or below the MRL. We typically don't require a specific calibration range, but a factor of 50 is typical. That's really laboratory determined. And then again, all linear and branched isomers must be accounted for in all samples. I won't go into a lot of detail again on the initial demonstration of capability, but these are the requirements as part of that IDC: blanks, precision and accuracy, the MRL confirmation, and then a quality control standard. And then ongoing QC. Each of these were discussed in some of the previous slides. So different reagent blanks, fortified blanks, the CCCs, QCSs, fortified matrix samples, and then we have our quantitation standards, either internal standards and isotope dilution analogs, or surrogates and isotope performance standards. FRBs, you heard James talk a little bit about this. This is something a bit unique to PFAS analysis, and it's primarily there just because of the prevalence of PFAS in the environment. What it's effectively doing is ensuring that you're not getting any kind of contamination occurring at the sampling site that's outside of what you're trying to sample. So there is an FRB required for each field sample location. But again, the analysis of that FRB is only required if you have method analytes greater than or equal to the MRL. A failure of that FRB does deem detections of that target analyte in the associated field sample to be invalid. We'll get questions often on method flexibility. I'll say as a general rule, as it relates to PFAS analysis, you can change things like the analytical column, your chromatograph or mass spec conditions, other consumables where it's listed in the method that you can use an equivalent consumable. But often you can't change the sample preservation, QC requirements, or extraction procedure. We would consider those changes in the scope of the method or the chemistry associated with the method. You should always follow the information that is prescribed in the text, and then anytime you make a modification, you do have to repeat the IDC, still verify all QC can be met, and run a representative sample matrix to ensure you're not having an unforeseen effect. All of these modifications should really only be considered improved method performance, not do things like just short analysis time. We understand that laboratories do want to get out results as quickly as possible, but we don't want that to be at the expense of method performance. We do have a program called the Alternate Test Procedure Program, where alternate methods that have new or methods that have been modified beyond the allowed flexibility of approved methods to get approved for compliance monitoring. This is the website associated with that program, and then those methods can be considered, evaluated, and then potentially approved either through a conventional rulemaking process or the drinking water expedited method approval process. So I won't go into a whole lot of detail on the regulations since James has already covered much of this, but again, just to reiterate, the National Primary Drinking Water Regulations highlight 6 PFAS that are regulated. There are 5 individual MCLs and 1 hazard index that uses 4 of those PFAS. I mentioned before that laboratories have to establish MRLs at or below the regulatory PQLs, and they have to meet the method MRL confirmation acceptance criteria. This is the table that James mentioned before, indicating the trigger levels, PQLs, and MCLs associated with all of the regulated analytes. So the rule does require systems to monitor for PFAS, notify the public of those levels, and then reduce the levels in drinking water if they exceed those standards. So I will highlight that the trigger levels listed on that table are used to determine monitoring frequency and are also used in consumer confidence reporting, but we don't have an expectation that those results are have to be quantitative, at least in the cases where the PQL is above the trigger level. So that goes back to the slide where I mentioned and discussed detection versus quantitation. So I just wanted to put that out there for information. Again, performance evaluation samples are required for certified labs. This is done annually, and they're also known as proficiency testing samples. And then the hazard index that's associated with the regulation, it's effectively a ratio between the measured results, or the sum of the measured results for 4 of the PFAS versus the health-based water concentration. And then you determine if that annual average for the hazard index is less than or equal to 1, which is the hazard index MCL. So most of the primary drinking water regulations with respect to PFAS are located at this website. There's general information for different entities, regulatory information, background, and then further information that gives a link to a website on PFAS Explained. And if there's ever any questions, we do have a safe water hotline where technical questions can be asked and they would get sent to our group, or you can contact me directly. Thanks.
We're going to go ahead and move into Sarah Conrad's talk. Sarah, yeah, and sorry, Sarah, I don't want to take up your time. So everyone's got your bio. So let's just go ahead and let you go for it.
Thanks so much. So I'm Sarah Conrad. I'm with the Arizona Department of Environmental Quality, and I wanted to tell everybody about a PFAS program that we're implementing through the Emerging Contaminants in Small and Disadvantaged Communities grant funding. I'll start with a little bit about our approach in Arizona. We've undertaken a substantial sampling project I'll tell you about. Also some resources we developed, some solutions we're undertaking, and then of course some lessons learned. So this is our our agency-wide PFAS approach. So we've got air, waste, and water, but all of the funding, or most of the funding, is in our safe drinking water group. So that's where a lot of the activity is happening. But we're fortunate to have an agency PFAS lead who sits over all air, waste, and water divisions. And then I'm in drinking water, and I'm managing the emerging contaminants in small and disadvantaged communities grants. We've also got Matthew Olson. Matthew is managing some separate state funding, as well as a sampling project that I'll tell you about. And then Yasmina is our senior drinking water engineer. She has a lot of experience with PFAS treatment. And so she has developed some PFAS decision trees that I'll just touch on, and she'll present at a later webinar about them. A little bit about the landscape in Arizona, especially when we're talking about our small communities, our rural communities. They tend to be groundwater systems. And we don't have any historical PFAS manufacturing in Arizona. So our levels are fairly low, still above the MCL in some places. But because of that, we haven't implemented a state standard. We'll be accepting the federal standard by rule. We do have about 1,500 public water systems in the state, and of those, 945 are regulated by the PFAS rule. But of those 945, only about 150 are covered by the UCMR5 sampling, which means that almost 800, or 85% of our other systems, are not covered. I think I've been through this slide, but because we realized that about 85% of the public water systems to be covered by the rule aren't included in UCMR5, we decided to initiate a statewide sampling project, and that's really focused on the small communities, 765 of them in total. And we're providing the data from this to the communities, to the public water system owners, but we're also building a database of this PFAS data and putting it on an interactive map that's public facing. We use $3 million of bipartisan infrastructure law funding set-asides to pay for the initial phase 1 sampling project. We tried to mirror UCMR5 as much as possible. And so we did 2 rounds of sampling. Samplers were taken at the EPDSs. We used both samplers under contract as well as in-house ADEQ staff. We have 2 dedicated PFAS samplers. And so phase 1 is just completed with 91% participation. And for that one, we used both of the 2 approved methods, and we took samples 90 days apart. And then when the rule came out, we began phase 2, which is really the initial compliance monitoring data collection. And since we had already started phase 1 and done the initial, we pretty much started phase 2 at 50% complete, because we had at least 1 sample for all of the participating communities. To help with costs, we did drop down to just 1 method, and we did have to pay close attention to the timing of our sample collection so that we could have both samples for systems to have for initial compliance monitoring. So here you have Hannah and Austin, our dedicated PFAS samplers, and they have been fantastic. They go out, they have a lot of communication with public water systems. They convince them why they should participate. A lot of times people aren't aware of PFAS and what the participation can bring to them. And so they've been doing a really great job to get 91% participation. And when we get the results, they're the ones to share them with the public water system, and then we post them on our map, which I'll show you in just a couple of slides. If we do detect PFAS, we provide the public water system with a toolkit, which basically lays out sort of their immediate next steps. And we do ask them to inform their customers, because this data is going to be on our interactive map, and we find it's better to be upfront about communication. So just very high level, what we're looking at for sample results, we have a ton of data and we have not yet had a chance to really dig into them. But what's interesting is that when we look at the DEQ sampling that we did, we get about 12% of systems sampled with PFAS above the MCLs, and that matches the UCMR sampling. But the breakdown for the not detect and detected below, those don't correlate as well. But like I said, we need to dig in and see what's going on with this data before we make any conclusions. Now switching gears a little bit to tell you about some resources that we've developed. This is our PFAS webpage, and if you click on the See More, where that first brown arrow is, it'll drop down and show you where to find the PFAS map, as well as the additional resources. We'll drop down and show you some more. You can get to this webpage either through the QR code or the URL that's in the title there. And so under the additional resources, you'll see the toolkit that I just mentioned and the decision trees that I will just touch on, but you'll have to come back and hear Yasmina talk about those in about a month. Here's our interactive map. You can see it's visually very easy to see what's going on. The red dots are PFAS above the detection, above the MCLs. Yellow is detected but below the MCLs, and green is non-detect. And you're able to click on any of these and it pops up with the data for that particular community. And you can get there directly through that QR code. So let me just go back to this slide quickly. You can see that we do have some clustered areas with red with PFAS detections above the MCL, about 3, one here in the southern part of the state, one in the north, really the central part of the state, and then a little bit to the east. And so what we decided to do is hire hydrogeology consultants to look at the hydrogeologic data as well as the PFAS sampling data and see if they could come to any conclusions about what we might do with the goal to give this information to the public water systems and help them assess what alternatives they might consider. We're currently this weekend and last week out doing some field work to look at some well investigations, cameraing a well, and then we'll be doing some dynamic flow profiling to see if we can identify where in the column the PFAS is entering the well. We've also done a couple of webinars that you can access through our YouTube channel through that QR code at the bottom. The first one, the PFAS 101, this was done in November of last year. So it is before the rule came out. And it is, as the title 101 implies, it's fairly high level. It's meant for water system owners and operators. We talk about what PFAS are, where they're found, what the regulations looked at the time. We talked about our sampling project, and then I talked about the funding resources we have. And this was took us about 3.5 hours to go through all of those topics. So today, this is a very condensed version. We also in November did a PFAS drinking water treatment webinar intended for engineers. So this is a very technical webinar. Tom Speth, who is the moderator today, actually presented part of the webinar, as did Yasmina. And this is a great resource, I think, broadly speaking, for engineers to use. We've also been doing some in-person trainings specific to PFAS. The first is the PFAS Forum, Industry Perspectives on Solutions, we called it. And we partnered with the Arizona chapter of ASDWA. And it was free, and we offered PDHs. So that really drew in the crowd. We had a wide variety of talks. We started with funding. We also talked about the permitting review process. We had a lot of technical presentations, as well as a keynote from an ASU professor. We had a really interesting panel discussion with vendors and manufacturers up there and sort of talking through what they might, what they look at when they consider a system and what treatment they might want to install. And at the end of the day, we had a vendor expo. So vendors could have tables so that participants could walk by and talk with them directly. We are planning to do that again next year, probably in February as well. And then we did a much smaller training specifically for small and disadvantaged communities and their operators. And for that, we hired a professional trainer who does PFAS training around the country. And we worked with him to develop the curriculum to make sure it was really focused on drinking water and what operators need to know about PFAS. Again, it was free with PDHs. And we did it both in 2 locations, and it was a 2-day training, and very successful, great reviews on that as well. And then the PFAS mitigation decision trees that we've developed. These came out in August, so they're fairly new. You can access them by clicking on that QR code. The decision trees, there's 6 of them. The first one starts with non-treatment. And I'll walk you through that one high level in just a minute. But if you don't get through the non-treatments and find a solution there, then the trees direct you to a general treatment PFAS tree, and then specifically GAC, ion exchange, RO, nanofiltration. And then finally, all the trees take you to simultaneous compliance. So we have significant funding in Arizona, as I know most states do. We have currently 42 million from the emerging contaminants in small and disadvantaged communities. That's federal funding, and we're expecting another 21 million within a few weeks. And then we have $5 million of a state appropriation. And so we're focused all of this on PFAS for small and disadvantaged communities. Most of the funding is going towards projects for public water systems. That's about 45 million currently. Then we'll add the 21 million on there when we get that. $1 million of the state money is going for continued sampling. And then the hydrogeologic studies I spoke about, as well as the outreach and training, those 2 total another $1 million. For the mitigation, when we're working with communities to help them with PFAS mitigation, we're doing it in a non-competitive way. So we have all the data from the sampling project, and with that data, we've developed a skills. I'm sorry, it's not a skills. A scoring matrix, so that the highest levels of PFAS are prioritized. So it's not competitive. We're not asking people to apply. We're reaching out to communities and asking them if they want to participate. We're working with them to find the most appropriate solution. And then this is key. We're contracting directly with the design engineers and the construction contractors and paying them directly. And this really minimizes the barriers for these small communities, simplifies the project management for them, for us to do it for them. Sorry, these aren't all showing up very well, but this is the pie chart that shows how we broke down the points, and you can see for the 6 regulated PFAS, they get about a third of the points. The next grouping of categories that receive points are based on the characteristics of the public water system. So if they're disadvantaged, what their population is, what their technical, managerial, and financial capacity is. And then we look at, I apologize that the labels aren't showing up here. The big green piece of the pie is no previous PFAS funding. So we have some communities in Arizona that have received significant levels of PFAS funding, but they also have disadvantaged neighborhoods. And so we wanted to be sure that they were deprioritized a bit so that we can really get this money to the systems that haven't had any funding yet to deal with PFAS. And then the gray piece of the pie is for co-contaminants. So if they have nitrate, arsenic, or other co-contaminants, we're able to use the federal funding to assist there, as long as the primary purpose and 51% or more of the costs are for PFAS or other emerging contaminants. So we really look to help the small systems and disadvantaged systems first look at all their options. We don't want to jump right to treatment because when you're talking about 50 people and putting in a $2 million treatment system, that just doesn't make sense. And so we want to look at things like consolidation, interconnections, maybe some well rehabilitation, just to really minimize the long-term burden of their operating, maintaining an expensive treatment system with media that has special implications of how it can be disposed of. So just to walk you quickly through the first decision tree, and then I'll give you an example, a real world example. So first we look at, are there other sources of water? Are there inactive wells or a neighboring community? We look at, does it make sense to drill maybe a new well or rehabilitate the existing wells? Can we switch to an inactive well or to a new source like a neighboring community? Blending doesn't usually look to be a great option for PFAS because of the parts per trillion MCL. And finally, if none of those are options, we go to treatment. So here's just a real life example of this little community here. They have PFAS above the MCLs at their EPDS. And so we're going out and we're sampling their 2 wells. If they have any inactive wells, we'll sample them at the same time. And we also do interference sampling at the same time so that we're gathering all the data we can immediately. A lot of our systems in Arizona rely on septic systems. And so if that's the case, we'll also do some sucralose sampling to see where, if there's any impact from septic in their drinking water. So once we've got that data, we do a high level review of what we might do. And we also look, there's kind of looks like an obvious solution here to interconnect to this larger community, which also does have PFAS. In this case, we are having conversations with that community, but the annexation could be a pretty big hurdle for us to overcome, even though that's only a couple hundred feet for an interconnection line. But this project is ongoing, so we don't have a solution in mind quite yet. But it's one of those situations where it looks like there's an obvious answer, but sometimes there's reasons it's not going to work out. So we gather all of this information high level, and then we hand it off to a consulting engineer, and we ask them to evaluate all the options and come back with a compliance options report. And here's the process that I've been walking through, where we select a system based on the prioritization, make sure they're interested in participating. Then we go to the Arizona Department of Administration's on-call list to find a design engineer. And we ask them to complete that compliance options evaluation I just spoke of. Once they've completed that, we sit down with the public water system and make sure that we all agree that what was recommended is the best path forward for the system. And then we ask that design engineer to design it. And all the while, DEQ is paying all the invoices. When we're ready to construct, we go to another list at the Arizona Department of Administration. This is the job order contracting list. We can get a construction contractor off that list, ask them to construct the option. Again, we're going to pay that directly, hand it back over to the system, and tell them they're responsible for the ongoing O&M and testing costs. Just a couple minutes on the procurement aspects, because that tends to be an area we get a lot of questions on. Excuse me. As I mentioned, the Arizona Department of Administration has on-call lists. These are cooperative statewide contracts that any state agency can use. So if you're not sure if your state has these, it might be worth a call to find out, because we were unaware just a few years ago of the existence of these lists. So for PFAS, we sent out a questionnaire to the firms on these lists and interviewed the ones that had PFAS experience. There were a couple of challenges there because every state agency can use these lists. Some of the contractors had some bandwidth issues, and some of them are national firms. And so while they might have had PFAS expertise, it wasn't local to Arizona. So we're in the process of creating a qualified vendors list. We're just right now developing the scope of work, which will include a menu of services. This way we can do a multiple contract award. So we're not limited to just one vendor, but we can get a list of vendors under contract and use them on an as needed, if needed basis for a variety of different activities specific to PFAS. If I have just a minute, I would like to highlight a couple of projects that we've been working on. The first one there in the list is a very small community that, their board of directors has sort of fallen apart, and the last one standing is an 80-year-old woman who's the only member of the board of directors, and they haven't raised their rate since 1999. So they are in need of some managerial and financial capacity building. So we're working with RCAC to help them increase that capacity. Once that's increased a bit, then we can go back and help them with some PFAS mitigation. Another system that's interesting is the second one. Our PFAS sampling came back showing they had PFAS exceedances. However, we knew that they had an RO system, so that didn't make sense. We sent an ADEQ engineer out who had a look and realized that they weren't treating the full stream with our RO system. And so they were able to optimize that. And hopefully the next set of samples will show them back in compliance. Then you can see we've got a lot of systems indented here. The ones that are indented are small mobile home parks that we're going to connect to the community right above them. And so right now we've got 6 of them in mind. We have more that we're just starting to work with. But this is a win-win. We get these communities clean water. The larger city or town gets another customer. And we're also able to help the larger city or town with PFAS as well. In the interest of time, I'll just go to my last slide, which is lessons learned. Suddenly there's a lot of buzz about PFAS. Everybody's got opinions. And so we really are trying to be very cautious that we know exactly who our expertise is that we're working with on our PFAS mitigation projects. If we're funding the project with some of our ECSDC funds, we'll be putting in best available technologies and not novel technologies. Well, we definitely need the research that's going into these novel technologies. For these small and disadvantaged communities, we really want to stick with what's proven. I talked a bit about the procurement list already and that we're starting a qualified vendors list. But another issue that's come up is that sometimes the communities don't want to participate. They don't want to look for problems because you'll probably find something. You might find that you've got nitrates or arsenic, or that it's right at the level that you need to start doing something. If we sample for coliform or perchlorate and those come back, then we're obligated to do something about that. So there's definitely sometimes some hesitation there into digging in deeper. And then finally, the can't predict the future bullet. In some of these systems where we're connecting smaller mobile home parks to a town, that can really change the way the town is operating their system. They may take a well that they hadn't been using very much, but now they have these new customers and it makes sense to start using that well. That can impact the hydraulics of the aquifer. We could pull in nitrates from septic systems. We could pull in more PFAS. So that's definitely something we need to keep an eye on. There's no answers there, but something that we are definitely keeping in the forefront of our minds. So that is my presentation. There's my contact information. Yasmina's is up there as well in case you have any technical questions on the PFAS decision trees.
Thank you, Sarah. So I'm back. So my speakers went out, and I apologize. Hopefully, our viewers aren't having similar issues. So yeah, I think we have a little time because we have a half-an-hour break. So I was going to ask Sarah a couple of questions that popped in. So the first question is, when you get a high reading, do you go and try to look for the source of the contamination, say taking soil samples, or do you try to find the source of the PFAS?
At this point, we're not. We need to be in compliance with the drinking water MCLs within just a few years. It's not a lot of time. And so we're just treating the drinking water for PFAS.
Great. And while that's going on, while it takes time to construct the well, what is the policy toward the supplying water to that community?
Well,
I think the question is, do you provide bottled water or not?
At this time, we're not, because the MCL is not in effect until 2029. For other contaminants, we are, but not for PFAS.
Okay. And how does one access the PFAS 101 or treatment seminar? Is that available?
Yes. So there was a QR code on that page that you should be able to scan that. If not, if you go to our webpage, on the left, there one of the items is called something like drinking water videos for PFAS mitigation, and that'll bring you to our PFAS YouTube channel playlist.
Okay, great. Thank you very much, Sarah, for your presentation. Wonderful. And thanks for putting up with our technical difficulties that we ran into. So, and I apologize to the audience also if we ran into some issues and we ran a little bit late. So we will be taking a break until 3 o'clock Eastern time. You'll see a slide pop up on the screen that says taking a break, but we will get back to you at 3 o'clock with our final two speakers. And so stay tuned. Don't drop us, or if you have to drop us, pop back in at about 3 o'clock, and we'll pick up the seminar at that time. Thank you so much, and we'll see you then.
Okay, we're at the top of the hour, back from our break. This is our PFAS webinar, part of our Small Drinking Water Systems webinar series, which is a partnership between EPA and the Association of State Drinking Water Administrators. Marie, could you go to the next slide real quick? Just a quick announcement before we get started. Just a reminder that these webinars today are talks from our 21st annual Drinking Water Workshop that was held actually last week in Cincinnati, Ohio. So all of the talks today are from that workshop, and also on October 29th, we're going to also have a series, a 3-hour extended webinar on rule implementation and treatment. We have more details coming. Registration is open so that you can prepare to join that and get that on your calendar, since it will be 3 hours. Okay, with that, I'm going to go ahead and get started with our first speaker. After each of the 2 remaining talks, we will have a short Q&A. And just for all attendees, we do have close to 2,000 people on this webinar, so it is very challenging for us to get to all of the questions. We do the best we can, and some of the speakers may respond directly, but it's just not possible for us to get to all the questions. So thanks for your patience on that. We'll do our best. And with that, Erica, if you want to get your start getting your slides up, I'm going to introduce Erica Calvi with California Water Resources Control Board. Erica is going to start talk today about characterization of the class of PFAS in California. And Erica, we can see, great, we can see your slides. Can you do a voice check?
Yes, can you hear me okay?
Perfect, yep, we can see you.
Right.
Thanks, go ahead, Erica, thank you.
Awesome, thank you so much. And yeah, thank you so much for having me here today. It's really a pleasure to be here to share the results of this drinking water methods comparison study that is associated with the critically important PFAS broad spectrum project that we're working on here in California. My name is Erica Calve. I'm a senior engineering geologist and supervisor for our pretreatment and constituents of emerging concern unit, or the CEC unit, in the Division of Water Quality. I have the pleasure of working closely with our state lead for PFAS, Wendy Link, and our partners in the Division of Drinking Water, or DDW, including our Assistant Deputy Director, Dan Newton, and our PFAS Technical Lead, Eugene Long, and our Senior Environmental Specialist, Mariela Carpio Obeso. The State Water Resources Control Boards, DDW and DWQ, have coordinated PFAS investigatory efforts since 2018. These efforts have resulted in an understanding of the occurrence of PFAS, those that are most well known and can be detected using targeted analytical methods in both public water supply wells and at industrial source sites around the state. But we are acutely aware that targeted analytical testing methods provide information on those PFAS that were most well researched. These PFAS have been phased out, and new PFAS chemistries that are used by chemical manufacturing companies have brought forth multiple other groups of PFAS that are not well studied to date. Where the initial statewide investigation efforts relied on targeted testing methods to understand the presence or absence of PFAS, we're now moving in a direction to get an understanding of the rest of the PFAS that may be present but are not characterized by existing targeted methods. This should provide the opportunity to evaluate, more PFAS, including those that have are part of the replacement chemistry. So this broad spectrum approach for PFAS is unfortunately not just one analytical testing method, but it's the use of multiple methods in order to understand the broadest chemical space possible using commercially available testing methods. It includes both targeted analytical methods, including an ultra-short PFAS targeted method, and then non-targeted analysis and a total PFAS method, the best that could be available at this time. And that's the method referred to as adsorbable organic fluorine, AOF, by combustion ion chromatography, or CIC. We are currently using this approach as part of a community water system sampling project that will be described in a little more detail later. And before we dive in, this slide provides some background information that helped lead us to the development of the broad spectrum PFAS project. This was a small scale study that was conducted in 2021 to support an evaluation of US EPA 537.1, which was the drinking water method that was used at the time to satisfy PFAS monitoring requirements for drinking water, and to compare the results from using US EPA 533 to decide whether or not we would transition to US EPA method 533 to support ongoing PFAS monitoring in drinking water. The study included 9 drinking water supply wells that we went out and collected samples from, and then we had the samples analyzed using 5 different testing methods. And we included AOF by CIC, which at the time was kind of potentially going to have too high of a detection limit for drinking waters was the current thinking, but we included it anyways. And we're surprised to find that at least in some of our samples, up to 70% of the reported sums of targeted PFAS were not accounted for in this total PFAS concentration that was analyzed by AOF CIC. We were able to conduct suspect screening for non-targeted analysis, and we were able to confirm that, in fact, there were several other PFAS compounds that were identified with a good level of confidence that were present in our samples, but not included in the targeted analysis. So this information highlighted an enormous data gap that remains when you use targeted analytical methods to characterize PFAS in drinking water. And as a result, there was much interest in applying a broad spectrum approach to characterize total PFAS at drinking water supply wells throughout the state. And to do so, the state legislature passed the Budget Act of 2022 that included appropriations to support the Division of Drinking Water to achieve these 3 primary objectives. First, to develop and validate a broad spectrum test method for the class of PFAS, and that's this method comparison study that I'm sharing with you today. And then to sample nearly 4,000 public water supply wells serving disadvantaged communities throughout the state using that broad spectrum approach. And then third, to develop a treatment-based regulatory approach for PFAS as a class. So now diving into the PFAS method comparison study that was developed to help identify the best broad spectrum PFAS method for the statewide sampling approach. The primary objective of the study was to identify the most appropriate broad spectrum analytical method for characterizing the occurrence of total PFAS in drinking water. The most appropriate broad spectrum analytical method will be one that's reproducible, robust, with a high potential to support feasible ongoing monitoring. The secondary objective was to characterize the chemical space that is captured by available broad spectrum analytical methods. Going into the study, we knew from our own experience and from speaking with experts across the globe that the chemical space associated with the class of PFAS is very complex, and there's not likely going to be one method that really covers the entire space. So one of the things that this study helps us do is characterize the uncertainty and limitations of the most appropriate total PFAS method, such that those limitations can be factored into consideration when interpreting the results of the selected broad spectrum test method used to characterize the occurrence of PFAS at public water supply wells, source wells serving disadvantaged communities. So with that in mind, we included as many total PFAS analyses as possible in the study design. One thing that is useful to keep in mind as we explore the available methods, and it's lucky to present after Adam because he went over this and kind of described how a method development, really an analytical method can be broken into 2 parts. There's the part where you prepare the sample for analysis. It's often a form of extraction. And then that extract is analyzed on an instrument, and that's how you detect the parameters that you're going to measure. So part of our study design included multiple extraction techniques and then the analysis of those extracts on different laboratory instruments. as well as the same extraction method with the sample analyzed on different laboratory instruments. So to briefly list the analyses included in the study, we included AOF by CIC, as well as an extractable organic fluorine by CIC. We used non-targeted analysis using liquid chromatography by high-resolution mass spectrometry, or LC-HRMS, and we used 2 extracts, specifically an extract that is the same as the one that's used for the analysis of US EPA method 533 for targeted chemistry, as well as an extract that's created following the Department of Defense Quality Systems Manual Protocols, or DoD QSM 5.3. And then we got to work with the University of Notre Dame and used a method that's referred to as AOF by particle-induced gamma emission spectroscopy, or PIGGY. And we also got to work with Oregon State University to explore the use of fluorine nuclear magnetic resonance spectroscopy, or 19F NMR. I'll just say that where we tried to use these 2 different types of sample preparations on the NMR, including one that was analyzed as received, meaning as minimal sample preparation as possible, the detection limit of FNMR by the modified direct injection approach had too high of detection limits, and we were unable to measure any organic fluorine in the samples using that technique. So we didn't actually end up fully moving forward with that analysis. So we ultimately, we included as many PFAS methods that we could, but we could only include those that were available to us at the time. And so in total, we were able to explore 7 total PFAS analytical techniques, even though there are others that are of interest, but we did what we could with the resources we had. And then we supplemented that information with sample analysis using targeted methods. So we looked at both the results you could get from the targeted analysis by US EPA 533, and then we also looked at the results using the DoD QSM. And then we included an extra targeted analysis for ultra-short PFAS using ion chromatography, tandem mass spectrometry, or ICMSMS. We also conducted an analytical fate study for many of these methods, including AOF-CIC, EOF-CIC, ICMSMS, and LCMSMS using the DoD QSM extract. So even though we included, as many of these as we could, were only 2 broad spectrum methods that were readily available to commercial laboratories. So that was the AOF-CIC and EOF-CIC. And to keep this presentation relatively simple with regard to the data used for our decision-making process, this presentation focuses on those 2 methods. We have a link at the end of the slides that can get you to a memorandum that summarizes all of the results. And so, it is available for anybody who's interested in digging in a little deeper. So even though the results of the study are very rich and the data could be leveraged in many different ways by our team, from a really high level perspective, it's actually a really simple study design. We simply returned to the 9 wells that were sampled in 2021. We found that those had a nice range of PFAS concentrations detected in the environment. And so we wanted to go back and look at it closer with these additional analyses. We collected the samples, submitted them for analysis. Our contract laboratory did the majority of the analysis, but were also able to help us coordinate with the 2 university partners that we worked with. And then once all the analyses were complete and the results were made available, we compiled and processed that data and hosted a series of working meetings with folks that were interested in participating in looking at these results and to discuss them with us and share their perspective. Our goal was to compare the results to get a sense for the chemical space that was characterized by each method, and then to select the best approach for the statewide monitoring efforts. Our budget did not include method development, and so we really were moving forward with the best available that we could, but we also knew that our budget for the full-scale monitoring was going to allow us to include the targeted method, US EPA 533, at all wells, all 4,000 wells, and at least 1 broad spectrum analysis, which was going to be either AOF-CIC or EOF-CIC. And then at 20% of all of the wells included in the sample program, we're able to incorporate non-targeted analysis via LC-HRMS. And then you'll see that as a result of this study and kind of the awareness that we now have about the presence of ultra short PFAS in the environment, that we also decided that we can include ICMS-MS at approximately 20% of the wells that are included in the overall statewide study. So now just to dive in first to the analytical FATE study results. The analytical FATE study included between 1 to 3 spiked samples of several different types of compounds to see how they behaved through the sample preparation and analysis on the laboratory instrument, so we could measure the performance of several types of compounds that are of interest in the PFAS space. This includes 2 inorganic fluorine compounds, PF6 and BF4, in addition to fluoride, and then several subgroups of PFAS, including ultra-short chain PFAS, sulfonamides, volatile PFAS, and cationic PFAS. And as highlighted previously, the PFAS chemical space is complex, and that's why it is a huge challenge to find one method that measures total PFAS. With the methods available to us at this time, we had to weigh the pros and cons of the analyte fate of subgroups and how those were included in the final bulk measurement of organic fluorine present in any given extract. The trade-offs that we saw between EOF compared to AOF was that EOF technique was used to capture one of the inorganic fluorine compounds that was tested, PF6. And in fact, if that compound is present in a sample, the EOF technique would have resulted in a biased high result because the combustion efficiency of PF6 is also relatively high. We also saw that both methods have relatively poor performance for an important ultra-short PFAS, TFA, but in general, EOF does a better job on the ultra-short PFAS. AOF did a better job of characterizing sulfonamides, which we know from the LCHRMS results that those are a relatively important subgroup of PFAS for our study. Additionally, AOF did a better job of capturing volatile PFAS and cationic PFAS included in this study. It's notable that although TFA is poorly recovered, some TFA is recovered by both methods, and we have a sense for that breakthrough value based on the range of concentrations that were tested in this analyte fate study, and estimate that anywhere between 500 to approximately 1,000 nanograms per liter of TFA could be recovered via AOF-CIC or EOF-CIC. So now to dive into the 9 well sample results. This chart illustrates the range of detections observed using the different approaches. We found that by summing up the results from the 2 targeted methods, that includes the one, using a standard approach by LC-MS-MS, as well as the ultra-short analysis by ICMS-MS, helped to provide the most comprehensive understanding of total PFAS present in our samples. The other 2 methods, AOF by CIC and EOF by CIC, provide the bulk measurement of organic fluorine in the samples. And as you can see from our study results, these organic fluorine methods are sometimes capturing a lower concentration of total PFAS compared to the combined sum from the 2 targeted methods. Another thing that might jump out at you is the detection frequency for AOF versus EOF results. We collected samples for these 2 methods in triplicate, and we're showing here the average of the triplicate sample analysis. Taking those triplicate samples into account, we identified that we had approximately 85% detection frequency by AOF-CIC compared to a 15% detection frequency for EOF by CIC. I'll highlight again that our funding and the timeline did not provide the resources needed to fully develop or optimize these methods. We took what was available and we moved forward with the comparison as best we could. So it may be possible to achieve a lower detection limit for EOF than we were able to achieve for this study. But even if that were the case, we see that at the 2 wells where we did detect extractable organic fluorine in the samples, that we could be capturing less organic fluorine compared with the concentration measured by adsorbable organic fluorine. This has to do with the sample preparation process and the type of PFAS present in our samples. The extraction method we used is known to essentially, at least for the EOF method, it's known to essentially lose the sulfonamides, and you'll see from our LCHRMS results how important that subgroup is as we move forward with our statewide characterization results, our approach. And so now to really drill down a little further on the difference between AOF-CIC and the 2 targeted methods. Here we're breaking up the targeted method sums into the 2 different individual methods together. So we have the sum of the targeted PFAS measured via 533, as well as the sum of the targeted PFAS that are measured by the ultra short analysis. And you can see here that AOF, often where AOF is much lower than the total PFAS that we can get by the sum of the targeted results, is attributed to the presence of ultra short PFAS that are not well captured by AOF CIC. And so that's why moving forward, we're going to include ultra short PFAS analysis as part of our approach for characterizing the PFAS broad spectrum in California's waters. So the other key decision that our team was faced with, which was which extract to use when analyzing by LC-HRMS. It would be a lot easier and more affordable for us to simply use the extract that will be generated by the analysis of US EPA 533 on all of our samples. And then we could just simply use that same extract and measure it on the HRMS. However, the LC-HRMS analysis is expensive. And so we also want to make sure that we prioritize using the best extract for the project moving forward. So this chart provides a side-by-side comparison of the two extracts that were evaluated in our study, the US EPA 533 extract compared to the DoD QSM 5.3 extract. The results are reported as an abundance per milliliter. It is possible to implement semi-quantitative calculations, but for our comparison, we're simply using the data as reported and summing up the total abundance that's measured by each method for PFAS that could be identified at a good level of confidence. And then we report here that total abundance that's measured. And as you can see, for the PFAS present in our samples, the DoD QSM in some cases captures a higher abundance of PFAS in our samples. This slide provides a little more detail about that distribution as it relates to 4 subgroups of PFAS. We broke this up into the abundance for some of all of the sulfonamides that we could detect, as well as ultra short PFAS that can be measured via LC-HRMS, as well as cyclic PFAS, and then we have this other category. In general, we see the most significant differences when we look at the C3 and longer sulfonamides. This really highlights how important the extraction methods are when considering total PFAS. In this case, US EPA 533 was optimized to look closer at short chain PFAS, and it was not optimized for looking at sulfonamides. And that's why when we compare these two methods, the US EPA 533 does not capture much of the sulfonamides that could be present in our samples or that are measured by the DoD QSM extract. So what we identified here was that, we prefer the DoD QSM extract with regard to this subgroup. And then we can do similar comparisons with cyclic PFAS and other PFAS and some of the ultra short PFAS. And, again, like we're always weighing those pros and cons. And what we decided was that the difference in the amount of the measured sulfonamides was really important to us. And so since those cannot be measured as well by the US EPA 533 extract, then we decided that we would be interested in incorporating the DoD QSM extract with our study moving forward. So to summarize, we created these 2 lists to capture what's preferred and selected versus what was not preferred. For our broad spectrum analysis by CIC, we prefer that the method not recover inorganic fluorine. We would like the method to do a good job of capturing targeted PFAS as well as sulfonamides. And we're interested in semi-volatile PFAS and cationic PFAS too. For the extract that's used for the LC-HRMS, we chose the DoD QSM extract because we favor the performance of the sulfonamides in that extract and believe it does a sufficient job with the other subgroups of non-targeted PFAS that are present. We also prefer including the ICMS-MS analysis to help characterize targeted ultra-short PFAS that were detected in samples analyzed as part of the method comparison study. Until the deficiencies with the EOF-CIC approach that we used could be addressed to, maybe lower the detection limit and ideally incorporate sulfonamides, we would not prefer using EOF-CIC. We think that in addition to that, the fact that EOF-CIC captures at least one inorganic fluorine compound in the measurement is is unfortunate because we really want this to be an organic fluorine method and not have to caveat our results as potentially having present inorganic fluorine. So, so with that, that sort of summarizes the method comparison study and where we are today, which is, the path forward includes monitoring at over 4,000 public water supply wells serving disadvantaged communities. This particular work is funded via the state budget. And so since this is a funded project, the sampling is being performed at no cost to the public water systems. All of the samples that are going to be collected will be analyzed for US EPA method 533 using the targeted approach and the broad spectrum test method AOF by CIC. The samples from a subset of the wells will be analyzed for ultra-short PFAS as well as non-targeted analysis by LCH-RMS. Unlike the previous sampling efforts in the vicinity of industrial sources of PFAS, this study includes wells that are in rural, septic-dominated communities, agricultural communities, and cities not having known industrial uses of PFAS. And the map to the left shows the locations of those wells and what a great distribution it provides across the entire state. We completed the broad spectrum analysis, which is what I just shared with you today, and the method selection process, and began sampling at the public water supply wells in April of 2024. We've already managed to sample over 300 public water supply wells to date, and we anticipate that this part of the project will be complete in December of 2026. And then the data from this effort will provide incredible information to help us estimate the total PFAS present as best as it can be estimated, with and also provide some information on the non-targeted analytes that might be present and common throughout California's water supplies. We anticipate that the results from the sampling will also help us understand mixtures of PFAS across several geographic regions and help us kind of identify a likely list of PFAS that are common in all regions. It's also projected that once we complete this, we will begin testing at public water treatment systems, and we'll use data from that portion of this project to help us begin the regulatory process for a treatment-based approach for managing PFAS as a class. So now to take a little step back and just tell you that California is using a risk-based framework for monitoring of CECs in general. We have a CECs program, and we're developing a strategic approach to monitoring and managing CECs in the environment. To date, our approach has involved a really familiar risk assessment method where you take a predicted or measured concentration of a contaminant in the environment and compare those to available toxicity thresholds. That's a current process, which we refer to as traditional monitoring. But moving forward, we're going to expand our analytical toolbox, similar to what we're doing right now for the broad spectrum project, and incorporating more advanced monitoring tools to help us get in front of CEC issues and to assess CECs and CEC classes that are data poor, and for those that we don't have toxicity data. This expanded toolbox includes the use of non-targeted chemical analyses, as well as bioanalytical cell assays and other effects-based tools. And so we really want to promote and support the use of these advanced analytical techniques so that we can start to get in front of these problems instead of always kind of finding out after they have impact, after the impacts to the environment have already occurred. So with that, I also want to acknowledge that there were many people who helped us achieve the goals of the study to date. We had participation from many people at the US EPA, as well as environmental advocacy groups, researchers from across the country, as well as across the globe, our statewide laboratory and partners, as well as our other partners that are helping us implement the sampling program, including Sacramento State University and Geosyntec consultants. And so with that, I'd like to say thank you. And there's hyperlinks to our PFAS website where you can find a link to our memorandum that summarizes the results that I just shared with you today.
Thanks, Erica. If you can hang on for a bit, I think the best thing to do for flow here would be just to hold questions till after Alicia's talk, and then we'll just have a quick Q&A after that. Does that work for you?
Yeah, that sounds great.
Great. All right. Thank you, Erica. Okay, turning the floor over to our next speaker, Alicia Overbo from the Minnesota Department of Health, discussing something that can be challenging for many of us, and that's communicating risk and engaging communities around PFAS. Alicia, it looks good. Your slides look good, so good to go.
Great. Here we go. Perfect. Yes, good afternoon. My name is Alicia Overbo, and again, work in Minnesota Department of Health. And we'll be talking largely about PFAS risk communication and a little bit on community engagement as well. So just to set the stage, risk communication is a science-based practice that's meant to give people good information about potential hazards that allows people to make sound choices. Our goals with good risk communication are to ensure that our audiences and communities have accurate, consistent information to understand risk, identify ways to reduce risk, and have information and feel empowered to take action to reduce their risk. And a big difference between risk communication and other forms of communication like marketing is that we're really trying to avoid spin and provide balanced information to share with people to establish trust in sometimes stressful settings. So environmental contamination can be really stressful in communities, and it's really important to take that into account for contaminants like PFAS, because it really does affect how our audiences and communities are receiving information and applying it for their health. So it really does change the rules of our communication, and we need to keep that in mind first and foremost, that people who are experiencing stress or might be concerned about their health are going to be less likely to trust and remember information. This is something we know from extensive risk communication science and research. And for us to effectively have risk communication in a two-way dialogue with people about their health, it requires that we account for this emotion and its effects on how people think, and really start from a place of empathy and human connection. So another thing, though, I want to make sure we talk about for PFAS risk communication is that people can perceive risks differently based on the attributes of that risk or hazard. So they might be less accepting of a risk that is involuntary, controlled by others, is unfairly distributed, is human-made as opposed to naturally occurring, generated by an unknown or untrusted source. It's exotic and unfamiliar, and it affects children more so than adults. I mention this because PFAS does tick a lot of those boxes. PFAS contamination can be widespread, involuntary, and again, it's not a natural contaminant, it's a human-made contaminant. So it can trigger a lot of these sorts of feelings and concerns and amplify the perception of risk in our audiences. So it's really important that we keep that in mind compared to some other drinking water contaminants. So at Minnesota Department of Health, our approach for PFAS communications is really grounded in risk communication. And just to give an overview of what I'll be covering in the rest of the presentation, our approach really emphasizes close coordination with our state and local partners and really heavy emphasis on communications planning and developing clear, actionable messaging and making that available to systems and partners in case they have questions or need to use that in their own materials. And then creating accessible products and digital tools that really help meet people where they're at and provide information in a format that works best for them. So here in Minnesota, we have been working on PFAS for years, since the early 2000s. Much of this work was centralized in the East Twin Cities metropolitan area in communities that had legacy contamination from 3M disposal sites. And so a number of these communities in the East metropolitan area really are experienced with PFAS risk communication, and we've partnered with them at Minnesota Department of Health in a number of different community meetings, development of maps and informational resources. But up until recently, much of our risk communication was in this geographic area. And as we've scaled up our testing for PFAS across other parts of the state and eventually statewide through different state and federal testing initiatives, we've also scaled up our risk communication efforts. And much of this began in the year 2020 when Minnesota began its statewide PFAS monitoring, supported by EPA and clean water funds. And this sampling sampled 95% of our community water systems. It was a voluntary effort. And through that, we were able to cover 99% of our Minnesotans drinking water from a community water system. So we really did ramp up our communications efforts here to ensure that our systems were getting accurate, up-to-date information about PFAS And this is a few years ago where PFAS wasn't as familiar of a concept as it is now. And again, for them to be able to share that information back with their consumers. One of the tools that we have had in our toolbox is our drinking water risk communication toolkit. This is a website we developed that has tips, templates, and messaging that systems are able to adapt to support their communications about drinking water risks and help answer questions about health risk. And it's built in such a way that systems and other partners can use it in their communications planning for everyday risk communications, well-known issues that may be recurring, emerging issues such as emerging contaminants, and crisis communications. So there are a number of different tools to support planning, development of messaging, and dissemination to identify different channels and partners that can help get the message out there. So we partnered with several water systems to develop this tool and identify those needs. And it's something we've been very glad to lean on and rely on as we've expanded our communications for PFAS. Another tool that we ended up developing with our statewide sampling was our PFAS dashboard. And this is an interactive web-based dashboard we've used to house our PFAS testing status and results data. And at the time in 2020, when we were launching this, around 2020, we had our state health-based guidance values. So we were able to use those to really frame the risk for people so that if they were looking up the drinking water PFAS testing results for their community, they could see how it would compare to our health-based guidance and make informed choices about their own health risk and any actions they might want to take to reduce their PFAS exposure. We've now updated that to incorporate the final MCLs as well. So as we began this statewide testing initiative and launching this dashboard, we really put a heavy emphasis on communications planning. And if people take nothing else from my presentation, please remember, communication plans are your friend. This is something that we really are invested in our program. It's been very successful to ensure that we're communicating with our partners thoughtfully in the right order and that people are getting accurate, consistent information at the right time. So we were very thoughtful about this with the launch of this PFAS testing and this PFAS dashboard to ensure that our staff, close partners, had information and had messaging available so that if they received questions from systems and from partners, they were up to date with this information and could share updates and information as well. And we worked closely with our community water systems to provide talking points, provide information about PFAS, because again, this is a much newer term for many of our general consumers. And we also made sure to notify our local public health because we knew that they would likely get a number of questions from our private well users. So as part of this type of planning effort, we really place a strong emphasis on developing messaging to share with partners, disseminating it electronically, and then using a number of different tools and outlets to make sure we're reaching Minnesotans, like the webpage, press releases, social media as relevant, and then any questions that we receive or that our partners we receive, we make sure to incorporate any additions and improvements in our own messaging. And again, this is a playbook that we've now used for the draft PALs, the draft MCLs, and the final MCLs that we really made sure to proactively develop messaging to share with our public water systems. It's something they now ask for when they know some of these big changes are coming. And so we know it's getting used, we know they value it. And we were able to use the messaging made available by EPA about the final MCLs, but in Minnesota, knowing that a number of communities are really familiar with PFAS and that they already are familiar with our health-based guidance values, we knew they would have some really nuanced, advanced questions about PFAS. We wanted to make sure we were able to answer questions about health risk, share information for systems to answer questions from their consumers, and share information with our staff who might be getting those questions as well. So we made certain summarized talking points to share with partners, and then more detailed talking points to respond to media and for our own technical staff. And again, a big thrust of this effort was really evaluating how to incorporate our own existing state guidance values into our PFAS risk communications and really our PFAS risk management approach as a state. So after the release of the MCLs, we identified that in Minnesota, there are currently 18 systems or so that are affected by the MCLs. And a number of them decided to proactively start holding public meetings to inform their community about these developments and share information about PFAS. And again, as we've been working in this PFAS space for a number of years at this point, we placed a lot of emphasis on planning and planning with our close partners. So we partnered with the public water systems, the city staff, our state partners, including the Pollution Control Agency, our toxicologists and risk assessors at the Department of Health, and as relevant, our local public health partners as well. So we did a lot of pre-meetings to closely coordinate on the planning, the logistics, the presentation content to ensure we knew who was covering what, and that the audiences were getting the right information, and make sure we knew who was covering what, both for the content and for the questions and answers. Identifying any anticipated questions or concerns in that community so we knew ahead of time what questions they had and being able to determine who would answer what questions. And we also really covered the meeting logistics in a lot of detail. And I know some of our partners at the time thought it was overkill that we had so many planning meetings for the communications teams and for the presenters, but the end result was that our staff felt much more prepared and much more comfortable going into these public meetings, some of which were attended by several hundred people and recorded online. So they felt better prepared and better able to provide that information the way that the community was expecting it. Another tool in our toolbox is we really try to encourage where appropriate for public water systems and cities to use an open house format for their community meetings, even when there's going to be a public presentation about a contaminant or an exceedance of a different kind of contaminant. We really encourage having an open house ahead of time and after time. This does give a lot more opportunity for one-on-one, especially when people have detailed questions about their health risks, or about drinking water treatment in their home or any other particular concerns. And it's been a great way to have tables with our partners, to be able to share printed materials. And even at one of our recent meetings, we were able to have our partners set up a table for Spanish-speaking residents to be able to have interpreter services available. So now that we've had a number of these under our belt for the PFAS MCLs, we've identified a few success factors. One is having detailed planning with community and other agencies. As I've already mentioned, we were able to identify with one city, the brand new city administrator, that although she had thought everyone in the city was drinking city water, a manufactured home park within the community was a separate community water system. So it's really important for us to hammer out those details and provide accurate information for people with different water sources, including nearby private well users that we knew would be attending. Again, an open house format is really valuable. And if people have burning questions that they're coming in, they're able to talk to people right away and maybe listen, knowing that they've been heard and that their concerns are being addressed. A well-moderated question and answer session is very important. Sometimes these can get very long if the moderator isn't keeping a close eye on the time or knowing how to keep things moving. So we found it's just very paramount to have a moderator who is effective at controlling the time, making sure things stay on track, and managing sometimes difficult situations, and being respectful and understanding what questions we can cover in a large group versus what things you might refer to for the open house afterwards. And then lastly, we anticipate difficult questions. Again, in that planning, we try to identify any questions that might be hard to answer based on what we know, and really try to have messaging and responses available so our staff aren't on the spot, and I hope people can get the best information based on what we know at the time and share that with them. So as part of this process, we identified that, man, we have a lot of new staff. I'm not sure about some of the other folks on this call, but we had a number of different engineers and toxicologists that have been able to join our program, and also some staff changes. So some staff were really stepping into this for the first time, and it could be very intimidating. And again, the stereotype about scientists and having to get up and do public speaking can be very intimidating. So we made sure to have a few internal staff trainings, really starting with the foundation of risk communication, our risk communication principles, why it's important, and the psychology of risk communication. And then we went through some nuts and bolts and some tips on how to use key messages. We can develop great messaging and a lot of great resources, but if our staff don't know where to find that, if they don't have it in time or don't know how to use it and when it's appropriate to use that messaging, it's a waste of effort. So that using those key messages ensure that our messages are consistent across staff who might be attending public meetings and across communities who are having questions about PFAS and having these community meetings. We had training on difficult questions and practicing how to respond to questions, and then also using skills like bridging, where if there are difficult questions that are hard to answer based on what we know, or really off topic, that you can use phrases such as, that's a really important question that we get a lot. What we want people to remember is X. So making sure that we have tactics that people can get back to the main message, the key messages we want people to remember to protect their health. So again, having answered PFAS questions from the communities across our programs, across the years, we've identified a number of different messages we know are going to be questions we hear, questions about health risks for families, for individuals, concerns about why they're hearing things at this given time, practical questions about treating water and drinking bottled water, health risks for vulnerable populations or pets, and sometimes individual questions about health concerns. And when we work on our messaging and develop key messages to respond to some of these questions, we use the 27-9-3 rule for communications, which is based on analysis of communications in the media, where in print media, your average soundbite is 27 words, your average soundbite for broadcast is 9 seconds, and you have 3 main messages in your communications. So really trying to keep this plain language, not just to make sure that it's accessible for people and linguistically appropriate, but also to help comprehension, especially when people are feeling stressed. And we have identified a number of different factors that we really try to incorporate in our messaging. Again, some of our goals are that we're providing clear health risk messaging for different groups, including most healthy adults and adolescents, and certain groups or ages that have more health risk from PFAS, such as infants, fetuses, or parents who are pregnant, and affirming that everyone has their own individual level of acceptable risk. We are attempting to really present information in a balanced way so that people can see all the information. We're being honest and transparent with what we know, what we don't know, and what some of the different risks and considerations are. And people take that information and they use their own filters, their own values, their own judgment to decide what's best for them. We really want to provide actionable information on how to reduce exposure so people are feeling empowered and they either know the information on how to take next steps or they know where to get more information on how to take next steps. And lastly, acknowledging uncertainty and changes in our understanding of PFAS over time, such as in Minnesota, where we know that we've had health-based guidance values for the last several years and decades, but they've gone down as we've learned more about PFAS over time. So explaining to communities why we are more concerned about PFAS now at the levels that we're seeing it, and being able to explain some of those science-based and research-based developments in PFAS. So my presentation has been pretty heavy on risk communication, but I'll give one quick slide on community engagement. Again, our public meetings have been one form of community engagement, and it's going to be different based on each community and each state. But another great outreach opportunity that we have been trying to capitalize on is our Minnesota Great Get Together, our state fair, where we host a drinking water exhibit. And this has been a great way to meet at least 100 to 200 people a day, talk to people from all across the state, sometimes from other states. And we know that this has been a forum where we've ended up receiving a lot of questions about PFAS. And again, it's been really valuable to have digital tools like that PFAS dashboard. Having those tools available, we've used them in different ways and in different settings than we could have ever anticipated when we were setting up the dashboard. Having those kinds of digital tools and resources mean that when you're having a conversation one-on-one, you can bring up someone's information and point them in the right direction for talking to people and for more information. So again, outreach and engagement can look different in different ways, but this has been a great and successful model for us. And we know that people have a lot of questions about PFAS. So it's the more we talk to people, the more questions we get and the more information that's getting out there. So in summary, our approach for PFAS communication has been really centered in proactive coordination and planning with our state and local partners, really heavy emphasis on communications planning and ensuring we're stepping in tandem as we move forward on PFAS remediation across the state, and ensuring that we have tailored, accessible information to ensure that Minnesotans are feeling empowered and have the information they need to make the right decisions for protecting their health. So this is my contact information. Glad to receive any questions over email, over the phone, and any other questions that people have right now.
Thanks, Alicia. Erica, do you want to join us on camera here, and we'll do we have a little bit of time for some quick Q&A. And Alicia, I'll give you a breather here and ask Erica the first question. Erica, there's a question about timelines here. So looking at California, what timeline do you have in California for the treatment rule? And how does your analysis fit into that timeline?
Yeah, that's a great question. And I don't know that we have, an explicit timeline. I think we're just, at this point, we know we're going to start the data collection efforts in 2027. And then we're going to, it'll probably be 2029 before we're really kind of moving forward with figuring that out. It's going to be a little bit complicated. So I don't think, we anticipate that it'll take some time. And these methods play into that, in that we will we'll be using them to assess, treatment, existing treatment systems, as well as pilot systems, and collecting a robust data set to help guide the process and support a data-driven decision-making process.
I will jump in because somebody else jumped in for me last time when my system glitched. Okay, so here's a question. In California, is this sampling largely done by the state of California, or are there other organizations like Department of Defense that are also doing sampling around their bases, I guess? I'm paraphrasing this question.
Yeah,
does that make sense, Erica?
Yeah, for the broad spectrum approach, I think we're primarily doing the sampling, but in general, it's definitely both. So there are many others that participate in lead sampling efforts as well.
Okay, great. Okay, Alicia, this one's for you. Did you provide any information on relative risks versus other water risks or even other environmental risks the public is facing?
Yeah, that's a great question. So most of our PFAS risk communication has been specifically for PFAS, in that it's just been so prevalent in the media. And I mean, most of the times that we've had these public meetings about PFAS, that's what we're being asked to present on by our partners. But on the other hand, one of the things that we do really try to emphasize in our messaging, based on research done at Minnesota Department of Health, is that in many cases when PFAS levels in drinking water are really low, some of our researchers at Minnesota Department of Health have found drinking water is one of the lowest routes of exposure. So we really are trying to show with communities that if you're wanting to reduce risks from PFAS, look to other areas in the home and other exposure routes to really reduce your total exposure to PFAS and reduce risks in those ways. So for the most part, we've been doing single contaminant communications around PFAS, but we'll likely be looking at kind of broader contaminant messaging and some of our other sampling efforts.
Okay, great. Here's another one for you. You mentioned digital electronic communications. What percentage of the Minnesota population doesn't utilize digital or electronic communications?
That's a great question. I don't know off the top of my head, or don't recall if there's a specific percentage that doesn't use digital or electronic communications, but we do know in a number of our smaller communities in particular that there might be, and even areas in urban areas that might have less access to a certain electronic communication. So in our toolkit and in our works with community water systems and other public water systems, we do try to suggest other ways that people can get out information in their bill stuffers, sometimes in public notices for non-community water systems, and other print materials where appropriate.
Okay. Okay, here's one. Do you think that the forefronting risk can overwhelm people and create fear, or does this help create awareness? What is the balance? What is the correct balance?
Yeah, great question. Something that I've learned from one of my colleagues in the Department of Health is the seesaw effect, that if we as presenters are not concerned, the public will worry. If we're worried, the public won't worry because they think we've got it under control. So what you're really trying to do in your risk communication is bring both parties to the middle of the seesaw and really try to not have some of those dramatic swings. We're really trying to be balanced in how we're presenting the risks so that people are able to use their what's called systems 2 thinking. Our system 1 thinking and risk communication is what's concerned, what's fast, our automatic responses, but using balanced risk communication puts people in our psychological systems 2, where we're able to make more sound decisions and use more critical thinking when we're receiving information.
Okay, all right. Here's one for Erica. How do these analyses that you were talking about fit in with a treatment rule a potential treatment rule in California?
Well, I guess, at this point, we're really, need to do some testing and get some data to even start to understand what it might look like. So we've only just begun planning for that phase of the project, and there's a lot that we have to learn about treatments and how a broad spectrum approach kind of factors into our evaluation. So it really will be dependent on the results we get from future testing, and yeah, definitely stay tuned because we'll be happy to come back and share those results as we move down the way.
Okay, great. Thanks. Alicia, here's one for you. How are you measuring success on your communication efforts?
Yeah, they're all great questions. So we have been thinking about a number of different metrics, and admittedly, we've been so busy with PFAS that I think we're still in kind of reactive mode and not getting to do all of our thoughtful evaluation that we're hoping to do as the year dies down and we're able to look back. But we certainly try to look at our web metrics for one, our social media reach, sometimes our qualitative information from our partners who are working in communities to kind of see what's working and what's not working, including our community water systems. And I know another outlet we really want to leverage for qualitative information is some of our trainings and conferences with our water systems to really hear from them what their needs are, since often they're the ones who are really in the front seat, kind of having these direct communications with their systems. So yeah, I would say definitely a mix of some of our electronic metrics and outputs and some of our qualitative information back from partners.
Oops, I was muting myself. Michelle, are you back yet, or should I keep going?
Tom, you should keep going. I just keep getting low bandwidth. I'm sorry.
No worries, no worries. Mine bombed before, so yeah, I understand. Okay, here's one, and you might have touched on this a little bit. But I think it's for Alicia. Can you speak on how community-based organizations have been used to support PFAS engagement?
Yeah, great question. So I know in some of our site-based work where communities are dealing with contamination at a specific site, a lot of partnership is done with the state agencies and some of the community-based organizations that are either co-organizing the event or we know are going to be attending that event. So I haven't worked directly in some of those community-based site-specific contamination areas, but I know that's been a great partnership. And I think an area that we want to continue to work on in drinking water is developing some of our partnerships with some of our community groups who are really reaching some of the groups that we might not meet in our traditional channels and ensuring we're not leaving anyone behind.
Okay, and we're at the top of the hour, so I'm going to ask one kind of wrap-up question, I suppose, to each of you. So Erica, so of these analyses that you did, what is the most exciting or what is the most interesting thing that you ran into with regard to looking at the data and understanding the PFAS issue?
Gosh, I mean, this was a very rich study, and but we were so so grateful for the help that we got from the Office of Research and Development to help us understand and use high resolution mass spectrometry for this study. I am floored by the knowledge of your team and the team and your other ORD groups throughout the country. And we're so fortunate because basically they taught us how to incorporate this tool into our approach. And now we can take that knowledge and apply it to other projects throughout the state. And it's a very powerful tool. And, you know, I think probably the challenge is going to be how do you do risk communication with that? And I, you know, it is tricky, but it is also an opportunity for us to kind of take these advanced tools and try to get in front of this problem, you know, of CECs in general. So I would say that was by far the most exciting thing that we got out of it, even though I would also say just learning more about the PFAS chemical space and really getting firsthand knowledge about how important that extraction process is in your analysis, how much that can really influence what you can see and what you can't see, really understanding that like at a core level, I think was also a really powerful outcome of the study.
Right. And Alicia, so with regard to your work, you know, what is the take home that you would like to give everybody, you know, that one nugget that everybody should leave with that that could be really helpful to them?
I would say, well, it's hard to say just one, but communications planning and really working with systems on everyday risk communication. It can seem so big, but really starting with even just how they communicate with consumers about regular occurrences, boil water advisories, for anything. You can build a foundation for that up to things like PFAS, and really starting with some of those everyday communications and partnerships can really make communities more ready for tackling some of these more difficult and challenging issues.
Okay, great. Well, thank you both for these great presentations. And we're at the top of the hour, so I'll let everybody go. But thanks for attending. Next month, I believe it's the 29th, we have another host of speakers. So please stay tuned for that, and I hope you can attend. Again, thank you, Erica and Alicia, for presenting today. And this concludes our webinar. Thank you.
Thank you so much. Bye.
Bye-bye.